We are here to form a partial differential equation by eliminating the arbitrary function phi from phi over x squared plus y squared plus z squared, comma z squared minus 2xy is equals to 0. So we want to form a partial differential equation from this given relation. So step less as you listen. Now we differentiate partially with respect to x, y, and z respectively. Now, don't forget our function f of x, y, z is assumed to be phi over x squared plus y squared plus z squared, z squared minus 2xy. Don't forget also that this particular first argument is representing u and the second one is representing v. Okay? So now, differentiating this function with respect to x partially is going to give us what? The x will be equal to phi u dot multiplied by the x, that is partial derivative of u with respect to x, then plus phi v multiplied by the v, the x, that is partial derivative of v with respect to x. So okay, so we pick the u dx. The u dx, that is partial derivative of u with respect to x. Our u is x squared plus y squared plus z squared. By the time you differentiate u with respect, you have what? 2x. Then for the second one, the v dx, when you multiply, you differentiate v with respect to x also here, you have what? Minus 2y. Minus 2y. You are not concerned with x squared, you are differentiating with respect to x. So now by substitution, you have what? The f dx will now be equal to phi u multiplied by 2x plus phi v multiplied by minus 2y. So which invariably when you expand down, you have the the x will be 2x phi u minus 2y phi v. So let's call that one equation 1. Let's call that one equation 1. So now we do the same thing for y. We do the same thing for y. Let's do the same thing for y. Okay? Now we now differentiate partially with respect to y. So just let's change this to y. Okay? This will be y now. This will be y. This will be y. Beautiful. So that means the u dy will be, from here you have 2y as well. Then the v dy, this other one, will be minus 2x. Beautiful. So invariably it means what? Slotting it into this equation, you have the f dy will be, the u dy is 2y, so 2y phi u, plus the v dy is minus 2x phi v. So we can call that one equation 2. We can call that one equation 2. Now let's also differentiate. But by and large, we can look at what we could do. Don't forget this thing are equals to 0. So the first equation is equals to 0. The second one is equals to 0. So from here, let's combine them. Combine equation 1 and 2 together. When you combine equation 1 and 2 together, what do you have? You have what? 2x phi u is equal to, of course, if you are equating everything to 0. So equals to what? 2y phi v. So that implies that from here, we can have 2, we cancel 2. So we have what? Phi u is equal to y all over x phi v. So let's call this one equation 3. Okay? Are we following? Now I want to bring them together. I've gotten equation 1 to be this, I've got equation 2 to be this. So I want to get the value of my phi u is very important to me because that is what I want to remove. I don't want any values of phi again. So now that I've gotten that to be equation 3, you obviously see that since I'm trying to combine equation 1 and 2, I've got what we call simultaneous equation. So I can substitute for this value of equation 3 into equation 2 now. Oh yeah, let's go there. So now substitute for Now say substitute or put equation 3 into equation 2. Put equation 3 into equation 2. Okay? And equation 2 says what? Says 2y phi u minus 2x phi v is equals to 0. That's what we have in equation 2. So, which invariably means wherever we see, and obviously, before we do this substitution, this one can also be what? This one can be 2y phi u is equal to 2x phi v. I hope you understand that. Beautiful. So 2 will go. So you have what? You have y phi u. You have y phi u. Y phi u is equal to x phi v. So now putting 3 into 2. So that means wherever we see phi u, we put this there. So now we have y into y all over x phi v is equal to, x phi v. I hope you understand this. Because my phi u is now y over x phi v. So that's why I did there. So which invariably means if I expand this now, I will have what? Y squared and cross multiply phi v is equal to s squared phi v. Beautiful. So now you can see that phi v is common. So if phi v is common, so what happens? You can see now obviously y squared equals to x squared. So this implies that y squared is equals to x squared. And in that case, you can say y is equals to plus or minus square root x squared. So y will be equals to plus or minus x. Okay? Now, having done that, let's now look at the partial derivative of the function with respect to z. The partial derivative of the function, that is, the f dz will be equal to what? Will be equal to phi, u, the u, the z, plus phi v, the v, the z. Okay, so our du dz will be what's the given equation? Let's look at the given equation. Given equation is x, okay, x squared plus y squared plus z. So if you differentiate the u dz with respect to the first argument u, we are going to have what? Z, 2z. Very good. Now if we differentiate it with respect to v, that's the second argument. The second argument has z squared minus 2xy. So it's going to be what? It's going to be 2z. I hope that is correct. Okay. Yes. That's what we are given in the problem. Okay. That's what we are given in the problem. So now by substitution into this partial derivative of f with respect to z. So what do we have? Oh yeah, let's put it there now. Oh yeah. So therefore the f dz will be phi u multiplied by the u dz, which is 2z, plus phi v multiplied by the v dx, which is also what? 2z. So everything there is equals to 0. Everything there is equals to 0. Remember, everything there is equals to 0. Okay? So that means I can say that from here now we have phi u 2z plus phi v 2z equals to 0. So you can see that one will cancel out the other one. Okay? But which invariably means what is common? 2z is equal to phi u plus phi v is equals to 0. So if our z is not equal to 0, in this case, it means that suppose our z is not equal to 0, it means phi u is equal to phi v. Suppose z is not equal to 0, because ordinarily if we divide through by 2z, you have phi u plus phi v equals to 0. So that implies that phi u is equals to minus phi v. Okay, phi u is equals to minus phi v. Now, since phi u is equals to minus phi v, okay, since phi u is equals to minus phi v, you can call that one equation 4. Now let's putting equation 4 into equation 1. Good. Into equation 1. And what is our equation 1? I can't remember that. Let's check that. Equation 1 says x phi u is equal to y phi v. I think that's our equation 1. Okay. So that's our equation 1. So is that equation 1? No. All right. That's equation 1 says no. Equation 1 is 2x. Sorry, equation 1 is 2x. Putting equation 4 now into equation 1. 2x phi u minus 2y phi v equals to 0. Okay, that is equation 1. So which implies that we have 2x. Our phi u is now what? Minus phi v. Then minus 2y phi v equals to 0. Yes. So by the time you expand this, you have minus 2x phi v minus 2y phi v equals to 0. So bringing them to, taking this one to the other side, you have, in fact, you can even find, you can actually do the same thing you did the other time by finding phi v. Phi v is common, so you get, that implies that phi v will be what? Minus 2x, yes. Then minus 2x, this is minus 2y, yes, is equals to 0. Okay? Or whichever method you want to use, you can even divide by both sides by 2. Okay, I think that would be better. That would be better. This is barbaric. So by the time we have this, we have what? Minus 2 into x phi v, beautiful, then plus beautiful y phi v is equals to 0. Yes. So this one will not, this minus 2 divided, you have it. You have this one will lead us to x phi v plus y phi v is equals to 0. Because when you divide this 0 by minus 2, it's still 0. So x phi v plus y phi v equals to 0. So here, obviously, phi v will be 0. So you can say that phi v into x plus y is equals to 0, which implies that x plus y is equals to 0. So, and looking at what we had earlier we said y is equals to plus or minus x. So if y square is equals to x square, you can equally get x square is equals to y square from here, right? So x will be what? Plus or minus y. So that means y and x mean the same thing. They are equal to each other. Okay? They are equal to each other. Alright? So now, from here now, we can conclude that the equation is x plus y is equal to 0. So with this, we have come to the end of this exercise. So the equation we are asked to actually derive is x plus y equals to 0. It might look very, time consuming, but if you look at it all over again, make sure you don't make unnecessary mistakes that I made when I was doing it, so you will actually get it. So don't forget to click on the notification bell so that each time I upload a video, you will be notified. Thank you.